Fedora with Cosmic is a visual gem, but the best part is not aesthetics. The processor performance is amazing. Check these results. Watch out for the RAM. The reading speed outperformed almost every distro we tested. Pure optimization that you just have to see. Unlike in other videos this time, NVIDIA actually worked. Do you want to see the real performance? Stay. The data will surprise you. We entered the website, see the main versions and press Get Fedora. There are editions, atomic desktops, spins and also labs here. We choose Cosmic Spin. It shows a screenshot. Then we can see applications. We download the appropriate image for Intel systems. We boot the image and wait for the system to start. When it finishes booting, we see the Cosmic desktop and we click Install. We select the language, for example English, and the keyboard layout. In my case, I select Latin American, then we press Save Now. Now the date, the time, the target disk, and how we want to install. We select to use the entire disk, then we click Next. It asks us to enter the full name, user, password and confirmation. We activate the root account, its password and click Next. Now it presents a summary. We activate the box to install and confirm to erase and install. Then we wait for the process to end. When finished, we press Exit. On the panel we press the power icon. Then we press Restart and wait for the system to reboot now. The system boots. The speed of the first boot is fast. Then we wait for it to finish loading and enter the user's password. Now we enter Cosmic. It shows configuration, Wi-Fi, keyboard layout, time, location, the dock, and various other design aspects. Now we check the desktop, the panel, and the dock. We open the applications, which look stylish and organized. We select Home. We enter Cosmic settings and look for Input Devices menu. On the touchpad we select to activate right-click and then we close. Now we can show the context menu. We enter Change Wallpaper to place the classic Cosmic background, then we close the window. We open the terminal and increase text size. We run dnf install fastfetch sysbench to install the packages that we will use. In the initial setup, screen reader was enabled. We enter Cosmic settings, go to accessibility and disable this setting now. We run fastfetch and see that the kernel version is very recent. The idle memory is average and megabytes per package are low. Now we execute commands to check the information, considering the distribution version, the kernel, and the memory usage. We also check the space occupied on the disk. Then we verify the boot time by removing the firmware time, which is very fast. We run sysbench to evaluate performance, starting with the single-threaded CPU test. The events per second result is excellent. Then we run the CPU test with 5 threads to check the concurrency management. A very good result is achieved in this test. Now we evaluate the threads to see how concurrency is handled at the worker level in the system. The result obtained was average. Then we evaluate mutexes to check log management efficiency using 5 threads. The performance in comparison was average. With memory, we will evaluate memory reading to check how the operating system handles it. The reading result was quite excellent. Now we test memory writing to evaluate the speed at which data is written. The result obtained was very good in this process. Then we prepare the necessary files to test input and output. The sequential write speed obtained is completely excellent. We test with sysbench indicating that it is to evaluate random filio, meaning disk input and output. The result is very low. We run top to see the consumed memory. Then we run Firefox so that it loads a web page in the window without any extensions. We open a second tab loading a video. With this, we want to measure the average memory consumption when opening tabs together. Then we open a third and fourth tab to see the average memory consumed per tab. The result of the consumption was average. We update the system with sudo dnf update. This, in order to install the NVIDIA drivers, we see that it updates to kernel 7. We install with dnf the RPM Fusion repositories, both free and non-free, since in these repos we will find proprietary drivers. We run sudo dnf install acmod NVIDIA. Wait a few minutes and try the RPM QA command to verify the module and reboot system. This reboot will serve to load the NVIDIA module. We wait for it to restart completely and open the terminal for the tests. We validate the new kernel version with uname. And with NVIDIA SME, we check if we already have communication, but it is not so. We install xorg x113 NVIDIA CUDA package. Then, without restarting, we try to run NVIDIA SME again. There is no response. The module does not work. We proceed to remove the NVIDIA drivers. My card is not recent. We will try with the version 580. We search for packages related to NVIDIA 580 and the necessary ones appear to perform the installation with this older version. We install acmod NVIDIA, NVIDIA settings, xorg driver and CUDA 580 version. We wait for the process to finish. Again, we try with the RPM QA command to see the NVIDIA module, and after a few moments it already appears. We reboot now. The system boots. Now we see the module building. The reboot takes a little longer. At the end it enters and we type password. Now we run NVIDIA SME. If everything is fine, we install GLMark2 and Hashcat packages. With these apps we test graphics. We run GLMark2 and it uses the default card to render, which is the Intel card. Shading measures pixel and shader calculations. Ideas. This test renders abstract and logical scenes. Terrain renders a large 3D terrain with complex geometry for evaluation. Refract simulates light refraction through transparent surfaces. The score obtained by the integrated Intel card is excellent. We run GLMark2 with the environment variables offload and vendor to render with NVIDIA. Bump simulates relief using bump mapping. With the jellyfish test, many moving semi-transparent objects are rendered. Shadow evaluates dynamic shadow projection here. Loop evaluates loop efficiency inside shaders. At the end of the test, the score obtained by the NVIDIA card is excellent. We run Hashcat I, but you have to make sure device. Number 1 is the GPU. If there is a problem, install OCLETD and headers. We run Hashcat B, which tests CUDA using hashes. MD5 is old and fast, while SHA-1 provides much more security. SHA-256 provides greater crypto resistance. SHA-512 uses longer hashes and requires more resources. The result was great. The evaluation of Fedora 44 has finished. Now we close and turn off the equipment to give conclusions from the analysis made. In conclusion, Fedora 44 Cosmic is an impressive spin, good visual resources, integration, and a lightweight feel versus GNOME. It had good overall performance despite the disk speed, but what I liked most was the graphics performance with NVIDIA card. That is all for this video. If you liked it, subscribe, leave a like, and activate the notifications. See you in the next video.